Welcome back. In today's class, we are going to be seeing some practical implication of binary hexadecimal conversion. I have prepared a file that will demonstrate the use of this, but there are so many things that are still hidden behind the scene. But that is not an issue. But this demonstration will show you why it is important for you to see the reason why they are using base conversion. They are using binary, hexadecimal, then octadecimal, whatever they are using, okay? Now, this particular code, what I use this code for, I will explain to you later. I'm not trying to teach you Python programming yet. Calm down. There are a lot of things that you need to wrap together to become a developer engineer. But just see this as a practical implication of number conversion, okay? Now, I want to open a file. Let me make this one bolder more so that you can see. So this particular file here is called associationvideo.mp4. If you look at this, you will see a series chunks of hexadecimal number. You know that this is a series of hexadecimal number from the previous class that we should to ourselves what we have done in previous class when we converted binary to hexadecimal. Yes, this is hexadecimal implication of a particular video. This is a video file. But there is a mystery behind this scene. The mystery is this. What is the secret? Why are they writing this video in hexadecimal format? How well this particular hexadecimal format will be passed as binary to CPU to manipulate, to compute, and that computation will give us instance that we are watching a video. Are we living in an imaginary world? Are we living in a world where everybody has been manipulated? This is a world of mathematics. The ruler of this world are actually scientists, people who can manipulate numbers. They will make you see things as if it is happening. Meanwhile, those things may not happen at all, honestly. But just calm down. You will see what we are trying to do with respect to what this experiment is all about. Now, this hexadecimal file, if you look at it from our previous class, each digit here, each of these digits is a nimble. Remember that nimble is 4 bits, 4 digits of zeros and one. That is a nimble. So this particular 6 is represented as a nimble. This one is represented as a nimble. So if I have 2 nimble here, this is 1 byte. This is 1 byte. And if you look at this is 1 byte. Then these 4 digits here, they've become 2 bytes. If I now count how many 2 bytes is here, this is 1, 2, 3, 4, 5, 6, 7, 8. This is 16 bytes. This is 16 bytes together. This is 16 bytes. This is 16 bytes together. This is 16 bytes. And we are converting to base 16. Is there a mystery behind the number called 16? Those that look for mystery, is there a secret behind the number called 16? In Yoruba land, there is something we call Ifa, the oracle, and that is also operating on 16. The 16 sigil, this 256 sigil is formed by 16 by 16, 256. I think there is a particular mystery behind this 16, and inside 16 there is 6. Can you figure out something? But that is not where we are going. So this is 16 bytes. This is 16 bytes. Then how many lines do we have here all together? How many lines do we have here all together? We are having 579,689 lines. But this last line does not complete. It remain how many? 1, 2, 3, 4. It remain 8 bytes. That is, this place is just 8 bytes. Are you getting me? So it does not complete 16. So what are we talking about? Let us see, maybe we'll be able to get the total size of this file by multiplying everything together and see how many bytes it is there. Let us calculate the total number of bytes in this place. You know that each line is 16 bytes. To calculate the number of bytes, we multiply 16 by the last line and subtract 8. Let us see what is going to give us. Are you getting me? So, do we have a calculator? Let us bring out our calculator and let us perform the calculation and see what we are going to get. We are having 16 bytes per row. Is that not it? So we have how many rows? We have multiplied by, we have how many rows? We are having 579 rows, 579, 6, 9, 6, 8, 9 rows. Then what is our answer? Our answer is 9,275,024 bytes. But remember that this last one does not complete. Let us remove the 8 out of it so that we are going to have the total file size. What is the total file size? The total file size is 9,275,016. Yes. Is it correct? Let us see. We are going to use PS shell with this PowerShell to see the size of this file. This directory, I open it in my PowerShell terminal. So let me just clear everything in this place. See, let me make it bolder so that you can see what I'm doing. So CLS. Now I have cleared the terminal. You can see this directory here. That is O1 media under the disk label as D. So that means to say we are operating at where is 01 media then association file.mp4. Let us list the content of this file. If I want to list the content of this file, I can say get content of this particular file. Are you getting me now? So association _video mp4. If I get content of this file, it will print out everything on that file as it is. Are you getting me? But if it print out the content of this file, what am I going to get? Am I going to get hexadecimal? Am I going to get hexadecimal? Is it true that I'm going to get a decimal or I'll get something else? Let us see what we are going to get. Can you see? Gibberish. We didn't get hexadecimal. This is another application entirely that does not read that content as hexadecimal. I have another program which is this Sublime that read the content as hexadecimal. If I read the content in VS Code, this is the content in VS Code now. If I open this in VS Code, it will bring out the video. It will not bring out the hexadecimal. What is the issue? These are several programs, are you getting me, that convert the binary that is stored on the disk into different formats. I am telling you, the actual format in which this file is saved on the disk is binary. I don't know if I am wrong, but if there is something that you believe that is wrong, let me know. But with respect to my own research, I get to know that this file is written to my disk, are you getting me, as hexadecimal. For that reason, different program will read it differently. So PowerShell read it as gibberish. Are you getting me? My Sublime program read it as hexadecimal. My VS Code read it as video format. So for that reason, it depends on the format that we want to see it. Now let us get children of this place. Are you getting me? Let me get the children of this directory, we get child items of this directory. It will list everything in this directory, and let us see the size of each item. So look at it here. Look at it. This is the mode is append mode. Then the last read time. These are the metadata that come with the file. But this is where we are going to look at the length of the file. Let us look for our file, which is what? association_video.mp4. What is the size that we calculated? We calculated 9,275,016. Is it the same? 9,275,016. This is the easiest way. Every program calculates the size of everything that is written into a program. You can see that there is power in binary and hexadecimal. But what I want to do in this program is that I want to read those hexadecimal, which is byte array, into bits. I want to read the bytes array into bits. So this is I think this is what we call byte. I have said it. This one is what? 1 byte. These 2 digits is 1 byte. This another 2 digits 1 byte. So this 4 digits is 2 bytes. Are you getting me? Now we want to convert all of this into binary. In order to do that, I wrote this program. Don't mind this first aspect. This particular function. You see, you are still going to do function in mathematics. Everything that you are doing in mathematics is not jargon. It's not something that's not practicable. It's just that you don't know their application. Whenever we want to define a function in Python, we use this definition. Are you getting me? But to me, it does not really convey the real meaning why we are defining a function. Maybe they have to look into this. JavaScript is one of the best programs that actually shows that definition, because in JavaScript, to define function, you will write function and the function name. So this is how everything is defined in normal program. But for Python, they don't do that. Are you getting me? So whenever you see this keyword in Python, it actually means you are defining a function. But this function has a name called read file. This particular function, what am I doing? I am reading a specific file that I put its part here in junk, and I am reading 1 kilobyte. This is 1024, which is 1 kilobyte at a time, and I'll print it out to the console. So if you are going to say I will read this, I will execute this program, because in this program I actually execute the two functions: read file to read the content of that file, and an hexadecimal to binary for this particular one. So, and I write that binary to this destination. You are going to see that destination. So now this program here, I use it to read the content from the source, which is the source here, and this is my destination. Are you getting me? So, and I read it in junk, I convert it to binary, and I write it to the destination file. It's no more than that. So if I want to run this program, what will I do? I will have to identify this file and use Python to run it, because I am inside this file already, in which I have done so before. Let me read it. So this is Python. This is the executor. This is the program that read every Python file. This is the program. This is the compiler or transpiler or interpreter that actually, because Python is an interpreted language, not compiled language. So this is an interpreter that actually take your file, read the content of it, and execute it. So what am I doing here? I am using this program. This is the file name. Look at it here. So this is the file name. Look at it. Hexadecimal to binary.py. So when I do that, I will execute this particular function here. It will read this file and output this file here. So although I have run the program before and I have the output here, are you getting me? But I want to delete it so that you will see what it will do. It's trying to open the file. Let me wait for it to open so that you will see what is inside the file in actual sense. Are you getting me? Now you can see that's what is inside the file, but this file does not complete. Let us delete it. It has been deleted. Now let us execute the Python file again. Enter. So what is happening? The first function that I wrote here is reading the content of this file in hexadecimal, because MP4 file are actually byte file. Are you getting me? It's actually byte file. So this one is busy reading the file, writing the content to the console. That's the reason why you are seeing all this one inside this place. You can see that it takes some while before this one can have actually finished, because what is happening is that this one is executing its own function, reading the content of this file, writing it to this output, and let us see what the binary look like. So the video that you are actually seeing in the hexadecimal format, this is the binary format. It's coming up. It's coming up. Yes. What is happening? This is a whole series of long file. It writes this particular file, actually write everything in a single line. It writes everything in a single line. And what happened here is that my system is freezing because this particular file is very big. It's very big. It's actually freezing up right now. Okay, I have closed it. So what is happening? Do I have to append new line to the file? So let us see if we can actually append new line to the file, then that one will be actually good. So according to the Python, if I use end keyword here and I say I want a new line, I don't know, maybe it's going to work or not, but let us just see. Maybe it's going to work. So we have append new line to every end of the 8 bits of their particular binary. So let us execute the program again. Whoa! Text input output wrapper dot write takes no arguments. It doesn't work. It doesn't work. That's the reason why if you want to become a programmer, there are many things that you need to put in place. That is where your requirement gathering is very important. So you are going to encounter a lot of issues. But what is very important is that whenever you want to do anything, do your requirement gathering, make sure that you have the necessary to make your program work. Each of this particular keyword, what they do is a tool for you as a program developer engineer to actually see what it's going to be like. So this one cannot work for me. Okay. So then let me see, maybe it's going to work here. Let us see, maybe it's going to work there. So that program is executing, that program is executing, that program is executing, that program is executing, that program is executing. I'm not going in a rush. Yeah, it has finished executing. Okay, let us see this one here. So let's see, maybe it actually executes without error. Okay, so let us see what we are going to get here now. Let us see what we are going to get now. Yes, can you see what we get now? So it actually works. You can now see, I told you that each line I am reading 8 bits, and you can see that each of this is 8 bits. You can see each of this is 8 bits. But how many lines are we gonna have? Look at it. Jesus, can you see we are having 9,275,017? That is to say there is extra 1 bit that is added. Do you see that? Because we know that 8 bits is equal to 1 byte. For us to see the actual size, that's the reason why I use the new line termination to terminate that program and enable you to see that we can read each of those 2 bytes inside our, you see, inside each of this. Okay, see, this one here is 1 byte. I get me. We read each of the bytes and we write it into this, and we append new line, So in actual sense, I'm not saying directly that this is what your CPU will read. Your CPU will have issue reading this, because this format is very bad for CPU. The reason is because there is what we call new line that end every line. If your CPU will read it, your CPU does not, I don't think your CPU will understand you now. Everything will be written together. Everything will be written together in a single line. Your CPU will read it just like Turing typewriting. Are you getting me now? This is exactly what is happening in file system when it comes to programming language, and this is the reason why we have different kind of file formats and different kind of way to deal with them. If you want to become a programmer or you want to become an engineer in this particular field, you need to understand different file system. What are the tools that we need to handle them? Where is this stream coming from? Where are we reading from? Are we reading from network? Are we reading from file? Are we reading from terminal, which is standard in? Are you getting me? So this is everything that we need to demonstrate today to actually show you what we are talking about when it comes to number conversion. You can see that everything that is written into our disk is binary, but every program take those binary, they present it to us in different formats. This is because in most cases, your terminal, they may not understand that binary if they should come the way they should. Then that is has to do with what we call low level reading. It has a lot of things behind the scene. It is something that you can do if you want to do it. Today, every research tools is in your hand. Learn how to use them. AI is there. If there is something that you don't, the AI cannot give you, you can research on all these research articles, journals. They are there. Some are free, some you need to pay. Then if you want to know more about the secrets behind how a file that is written in one particular format is converted to binary, and how CPU will take that binary and read it and understand it, then how the result of what CPU is reading is passed back to you to see, then you can go on further research. This is everything about this lecture today. Thank you for listening. ABP. Please guys, share this video, comment, follow, so that we can be encouraged to do more. Thank you for listening. ABP.